Alright, here's the practice test for Unit 2. Please try each problem before you watch the video. You will not learn it if you just copy me and that's all you do. So, with each question, pause it, give it a shot, then press play and see if you got it right or see if you need to fix it. Okay? Let's get started. Question number 1. Find the coordinates, sorry, as a typo, find the coordinates of the center and the radius for the equation x minus 4 squared plus y plus 6 squared equals 64. Alright, the center comes from these numbers, 4 and 6. It's the opposite of what's in here. So the center is going to be positive 4, comma, negative 6. So if this were plus and that were minus, that would be negative and positive. So opposite of what's in the parentheses. The radius is the square root of this number here. So radius is the square root of 64. So r is going to be 8. Question 2. Write the equation of a circle with center negative 3, 7 and radius the square root of 11. So this one we're putting it into the equation. We still want to do the opposite of the sign, so it's going to be x plus 3 squared plus y, that's a positive, so y minus 7 squared equals r squared, the square root of 11 squared. Square root of 11 squared is 11. So you're going to write your final answer to look like this. You're going to say it's equal 11. All right, question 3, make sure you're pausing before you press play so you can try it. The center of a circle is located on point 2, 6. Center, 2, 6. The point on the circle is 7, 3. Here's what we know. If my center is positive 2, positive 6, I know this part, x minus 2 squared plus y minus 6 squared equals, I just don't know the radius. So what we're going to do is we're going to take this point on the circle in the center and we're going to plug it into the distance formula to get the radius. Remember, the distance formula is the square root x2 minus x1 squared plus y2 minus y1 squared. So if I place my x's in the distance formula, x's are going to be 7. Here I'll put x1, x2, or y2, y1, and x2, y2. So if I plug these into the formula, my radius will be square root of 7 minus 2 squared plus 3 minus 6 squared. You may use your calculator or you can just work it out by hand. When I plug that in, it's going to be 5 squared plus, and that's negative. So anytime I square a negative, I use parentheses, negative 3 squared. And that's going to give you 25 plus 9. Remember, a negative squared is a positive. And 25 plus 9 is 34. So if my radius is the square root of 34, my center is 2, 6, what I'm going to do is I'm going to plug this back in for r, and I'll get my final equation to look like this. And technically you wanna square the square root. That's going to cancel those out. So it's just going to be x minus 2 squared plus y minus 6 squared equals 34 without the radical. All right, question 4. Pause it again. All right, this question is the endpoints of a diameter of the circle are -7, -3, and 9, 13. These are endpoints, so we do not have the center. We use the midpoint formula. Recall the midpoint formula is the average of your x's, x1 plus x2 divided by 2, and the average of your y's, y1 plus y2 divided by 2. So you can label these x1, y1 again, x2, y2, and get that stuff in the midpoint formula. That's going to be your center. So plugging those in, I'm going to get -7 plus 9 over 2 and -3 plus 13 over 2. Always add what's on the numerator before you divide by 2 or use parentheses if you're going to plug that into your calculator, please. So that's going to give you -7 plus 9, that's 2 over 2. And that's going to be -3 plus 13, which is 10 over 2. And then those divided by 2 are going to be 1, 5. That's your center. Your radius is the distance between the center and one of the 2 points. It doesn't matter which one, so I'm just going to use this one and this one. That's going to give me my radius. So the distance formula, I'm not going to rewrite it again, but it's x2 minus x1 squared. So 9 minus 1 squared plus y2 minus y1 squared, 13 minus 5 squared. That's 8 squared plus 13 minus 5 is 8. So another 8 squared. 8 squared is 64. And 64 plus itself is going to be 128. So since the radius is 128 and my center is 1, 5, I can plug it into the formula. X minus 1 squared plus y minus 5 squared equals the square root of 128 squared. A squared plus b squared equals c squared. So you're always squaring stuff. And the square is going to, again, it's going to cancel out that 128. And so that's going to give you a nice looking equation, x minus 1 squared plus y minus 5 squared equals, without a radical, just 128. Question 5. Write the equation of the circle K shown in the graph below. So it looks like the center here is at -1, and it's going to go up 2. So the center is -1, 2. And the radius, let's see, I got to go over 1, 2, 3. So my radius is 3. So I have the circle, here's the center, here's the radius. So let's write the equation. So I'm going to plug it in. Remember, it's the opposite, x plus 1 squared plus y minus 2 squared equals 3 squared, which is 9. And there's number 5. All right, question number 6. Again, make sure you're pausing between each time. What's the center of the circle with the general equation? All right, here we got to get that in a standard form. We're going to have to complete the square. So with completing the square, our goal is to get the x's together. So I have x squared minus 6x, and I want to get the y's together. So plus y squared minus 10y. And I want to move any constant that's on this side of the equation over here. I don't have anything over to the left side, but I do have a 5 on the right. So that 5 is going to stay put, because that's where it wants to be on the right side. And the next step is to give yourself some space. We're going to add a number to both the third term for the x's and for the y's. Whatever you add to the left, you must add to the right. The formula to get this number again is the b over 2 squared. That's the, just the positive value, 6 over 2. And then this would be 10 over 2, and we would square both those numbers. So in this case, it would be 6 over 2 squared. That's 3 squared. That's 9. That 9 is going to get put right there. For this one here, you would take the 10, divide by 2 and square it. That's 5 squared, which is 25, and that's going to go right here. So let me make those a different color. What you add to one side, you got to add to the other. So if I put a 9 and 25 here, that'll balance out the equation. All right, the next step is to factor what multiplies to 9 and adds to negative 6. Same thing here, what multiplies to 25 and adds to 10. And we want to add these together. So 5 plus 9 plus 25, the 5 and 25 make 30, so 30 plus 9 is 39. So I know that part's 39. We're almost done here. This is, this is going to be negative 3 both times, so this one's going to be 5 both times. Because 5 times 5 is 25, 5 plus 5 is 10, negative 3 times negative 3 is positive 9, and negative 3 plus negative 3 is negative 6. And we want to write that as one factor as a square. So it'll be x minus 3 squared, and this is y plus 5 squared, equals 39, of course. And the question wants to know the center of the circle. Well, the center of the circle comes from here. It's the opposites. So the center is going to be 3, negative 5. Okay, question 7. Use completing the square to put this in standard form. Anytime you have a coefficient in front of the square terms, we want to divide that out. So that's the first thing I would do here. We got a 2. I want to divide everything by 2, so I can cancel those out and reduce these. So this is going to be x squared plus y squared minus 8x plus 10y minus 25 equals 0. All right, we're gonna rearrange and complete the square. I'm gonna do this a little faster. So this is gonna be x squared minus 8x plus y squared plus 10y. This has a negative 25 on the left, so we're gonna bring that over and make it positive. The next step is to complete the square. So we want to add our third term. Do it to both sides. 8 divided by 2 is 4. 4 squared is 16. 10 divided by 2 is 5. 5 squared is 25. So 16 and 25 go here. This is going to be x minus, that's a negative, so x minus 4 squared. 4 times 4 is 16. Negative 4 plus negative 4 is negative 8. This one's going to be y plus 5 squared. 5 times 5 is 25. 5 plus 5 is 10. And these three numbers, 25, 16, and 25, I know these two add to 50, 25 and 25. That's going to be 66. And it wants to know its standard form. This is standard form. So that is your answer. All right, question 8. All right, on angles. So we want to find this. This is called inscribed angle. Remember, the angle here is when it's on the circle, it's 1/2 the arc. The arc that it opens toward is on the left. It's going to be 195, so it's going to be half of 195. Half of 195. Put that in your calculator. It's going to give you 97.5. And there's A. B is asking for the arc. This time I want to know the arc that this angle intercepts. What's the degree of it? So since the angle is 26, B is going to be, 26 times 2 instead of divided by 2. So that's going to be 52. So times this by 2. We know that A is 97.5. I'm going to write that in here. And they want to know angle C. This angle is vertical. So I'm just going to throw that into the triangle and use 180. These three angles, C, 26, and 97.5, their sum is 180 because it's in a triangle. 26 and 97.5 is 123.5. So we want to subtract that from 180. And that's going to give you 56.5, I believe. All right, question number 9. Another angle question. This is an outside angle. The outside angle ends up using the we worked down in our notes, and on the board we had the angle equals, it's the big arc minus the small arc divided by 2, or 1/2 big arc minus small arc. So we don't have the big arc. This would be the big. This is the small, that is 55, and the angle is x. So let's figure out what the big arc is. All your arcs add to what number? I should add to 360. So if you add 130 and 55 up, that's going to give you 185. And if you do 360 minus 185, you're going to get, what is that, 175? Right. So your big arc's actually 175. Your small arc is going to be 55. We're going to plug it right in there. Okay, subtract these two. It's going to get you 20. 120, excuse me. And then that divided by 260. All right, question 10. All right, this is a central angle. This, when it's in the center, the angle is equal to the arc. So this is a pie chart. These are fast food preferences for students at Independence. 67%, 18%, 5%, and 10%. Question A wants to know the degree of the angle, the central angle that's associated with students that say they prefer McDonald's. So if you look at McDonald's, that's 67%. They want to know the degree. So we want to know 67% of 360 degrees since the circle's 360 all around. So to get a percentage, you change it to a decimal and you multiply it. And that's going to give me 241.2 degrees. Letter B says if Independence High School has 2,100 students, and they were all polled about how many would they say prefer Arby's. So Arby's is at 5%. We want to know 5%, and instead of 360, we want to know of 2,100. So 5% as a decimal is 0.05. Multiply that by 2,100, and you're going to get, hopefully, a whole number, 105. And that represents the number of students. Okay, question 11. I want to find x. X is an arc. 100 is an arc. This angle's inside, so we're not going to subtract. We're going to add the arcs. But first, that angle is not the angle we're using. It's got to be this angle here, or this one, the vertical angles, because they got to be facing the arc. You understand? So you can use 45, but you're going to get these arcs, not the ones on the left and right. So to get this angle here, or that angle, you're going to subtract from 180 since they form a line. And that's 135 degrees. All right, the formula that we used is angle equals arc plus arc over 2. Now what we have is we have the angle, that's 135. Don't use the 45, use the 135. The arcs are 100 and x. Let's multiply that 2. And 2 times 135 is going to be 270. So subtracting out that 100, that's going to be 170. All right, question number 12. All right, in the figure below, PR and SR are tangent. Tangent means that those lines are going to make right angles with the radius. PR is 8 centimeters. OT is 6. In this problem, what you want to do is you want to write the radius in different spots so you can see the connection. And I want to know the length of OR. OR is the hypotenuse. Okay, so that's your C. So it's A squared plus B squared equals C squared. 6, 8, that should be 10. We can work it out. Oops, that's 64, not 84. And those are going to add to 100. So the square root of 100 is 10. All right, question number 13. We want to know the perimeter of this triangle. Again, try to pause the video, see if you can figure it out. We're given the perimeter. My apologies. We're given the perimeter and we want to find x. So we got to use our rule that tangents coming to the same point, they're going to be the same length. So I'm going to go ahead and call that x. Same thing here. These 12s. And then the 17s. And we can add all these up together. This is going to be x plus x. And then this is 12 plus 12. And 17 plus 17. Those 6 segments end up being your perimeter, which is 84. So what I want to do is I want to add all these numbers. This is 24 and 34. I want to add those together. And that's going to give us 58. This will combine to 2x. So 2x plus 58 equals 84. And what we want to do last here is subtract the 58. And that's going to give you 2x equals 24, 26, I believe. And if I divide that by 2, I'm going to get 13. Okay, question 14. When you have a quadrilateral inside of a circle, opposite angles are supplementary, not congruent, but supplementary, which means that angle A and C add to 180. Same thing with D and B. So let's figure that out. A plus C is 180. A and C go together. The 12 and the 100 is 112. And then 180 minus 112 is, help me out guys, what is that? 68. So divide that by 4. And x is going to give you 68 divided by 4 is 34. Let's divide by 2. 17, I believe. We do the same thing with y. All right, B and D are linked together. They add to 180. Combine your like terms. Subtract your 140. — 180 minus 140 is 40, so 40 divided by 6 is 40 divided by 2 is 20. 20 divided by 3. What that is? 6.66 repeating. Okay, question 15. Oh, thank goodness, this is a short one. All right, this is the center of the circle, which means that this segment here represents the diameter. Which means this arc right here, that's 180. Which means this angle right here, which is inscribed toward that arc, is half of 180. 180 divided by 2 is 90. So if you add these two together and subtract from 180, you'll get that third angle in the triangle, which really is this, angle A. Add these guys up. That's 146 equals 180. And then subtract the 146, and you get yourself, let's see, that's going to be 34. Okay, question 16. Hey, it's the tangent one again. Remember the tangent, the small circle here is going to go right to the edge. That's going to be 7. The larger circle we're going to put right to one of those points. That's going to be 12. Our goal is to find this segment. But before we can find that segment, we're going to use Pythagorean theorem to get the half of it. So if you square these and subtract, um, 144 minus 49 is what? 95. So the square root of 95 is a little under 10, about 9.746, 9.75. So we're going to, we want to find the length of BD. BD is twice that. So if I know that this is 9.75 and these two are congruent, then I'm going to add that to itself or multiply by 2. And times that by 2, you're going to get 19.49. All right, question number 17. We want to solve this for x. This is the one of those tangent outer, and then the whole thing would be the whole question. So remember the formula was outer times whole. In this case, it's tangent times itself, so tangent squared. So the outer is going to be 7 times the 7 plus the 9 equals x squared. 7 plus 9 is 16. So 7 times 16 is going to be what? 112. All right, to solve that for x, we're going to square root it. So it's going to be above 10. Let's take a second to find the square root of 112. I got 10.58. All right, question 18. All right, this one is we got segment lengths inside. This is the part times part. And part times part. That's what I used to call it on geometry, so I kind of stick with that still. The parts are going to be the two segments in the same, that are lined up, that are collinear. So CE and ED would be like the first two parts. So these two right here, it'll be 6 times 10. And then this EB is 4. We just don't know what AE is, okay? So I'm going to do 6 times 10 equals 4 times, I guess we'll call it x. And that's going to be 60 equals 4x. And 60 divided by 4 is going to be 15. Okay, question number 19. All right, we're into the sectors now. So the last section, find the area of the shaded sector if the diameter is 24. So the diameter is 24, the radius is 12. The shaded sector is actually over here, but the degree is representing this portion of it. So to get that degree, we want to do 360 and subtract the 260. That's going to be 100 degrees. So once you know that's 100 degrees, use the area of a sector of a circle, which is the area of a circle, pi r squared, times degree over 360. So pi r squared is going to be, excuse me, r is 12. Degree is 100. Don't use 260. Use the one that's representing the shaded part. And we're going to substitute that in the graphing calculator. So I'm getting about 125, oh, what was that? 125.66. Okay, question 20. Find the length of the arc ABC. Now, ABC is not this arc here. ABC is actually going from all the way over here all the way to C. So you're taking the longest path because that's the order of the letters, A to B to C. If this is a diameter, then this is going to be 180, and that's going to be 40. So the measure is going to be 40, the degree is going to be 40 plus 180. So that's going to be 220. The radius is 7. We want to know the length. Arc length formula is based off circumference, 2 pi r, degree over 360. 2 pi times 7 times 220 over 360. And that's going to get us 26.878, so 26.88. 0.88 centimeters. All right, we just got a few more, then we'll be done with the practice test. All right, question 21. This is the one like the notes. We're finding the area of this portion of the shaded sector. So what we do is we do the area of, make sure you're trying this out first. Pause it if you want a chance. Area of the large sector. And we're going to subtract area of the small sector. So the small is, think of this portion of it being removed from the whole thing, and that's why we subtract. So the large one is 7, has a radius of 7. So it's pi times 7 squared. The degree is 110, that's going to stay the same. And then the small one is going to have a radius of 4. So we're going to subtract this out. And we're going to use our calculator to finish the job. This one is 47.036. I think there were 2 6's there. This one is pi times 4 squared times 110 divided by 360. So this is going to be 15.358, so 36. And then the difference between those two, I'm just going to scroll up and press enter. And then subtract and scroll up and press enter. We're looking at 31.6777. All right, 22. All right, pause it please. Equation of a circle is given by x plus 3 squared, y minus 4 squared equals 25. We want to know the area of a sector. We got this part is the r squared, so r is going to be 5. Area of an 80-degree sector, we're just going to use the area formula, pi r squared. Degree over 360. We're going to plug in our 5 and our degree. So pi times 5 squared times 80 over 360. And that's going to get me about 17.45. All right, question number 23, and this is the last one on the practice test. Given the circumference of a circle is 60 pi, find the length of a 105-degree sector of the circle. All right, so first of all, I can get the radius. The circumference formula is 2 pi r or pi d. So if I substitute that 60 pi in for c, divide out the pi's so that they cancel, my diameter is going to be 60, which means my radius will be half of that. So we want to know the length of a 105-degree sector. So the arc length formula is 2 pi r times degree over 360, and r is 30. My degree is 105. And let's evaluate that and see what we get. So that's going to be about 54.98. All right, thanks for keeping up. This was the entire practice test. Stay tuned. There is a cumulative review sheet that has 10 questions from Unit 1 that I want to go over with you as well. I'll do that in a separate video. Thank you.